Good morning everyone, we are Group 6. Today we will introduce KBS 3 to you. The first part is the concept of KBS. The second part is how and why KBS 3 work. And the last part is some case study about KBS 3. KBS 3 is a technology for disposal of high-level radioactive waste developed in Sweden by nuclear waste management organization called SKB. If the holes into the rock from the cave are drilled vertically, the method is called KBS 3V, and if they are drilled horizontally, it is called KBS 3H. The only method considered so far is KBS 3V. Spent nuclear fuel is now basically stored in transitional storage equipment, and its danger is reduced continuously over time. However, it also contains substances that are active for a very long time, and these need to be finally disposed for many years to come. Therefore, KBS 3 storage method can be used for these materials that need to be decayed for a long time. The technology was developed by studying different natural storage facilities such as the natural reactor in Oklo, Garbin, and the uranium mine in Cigar Lake, Canada. The general theory is that radioactive rock in these sites has been present for thousands of years and has not affected the health and well-being of human populations.
The main method steps including the following. First, encapsulating the nuclear fuel in copper canisters. The copper canisters will have nodular cast iron inserts. The canisters have been constructed to withstand corrosion and the mechanical forces that can result from movements in the rock surrounding the spent fuel repository. The sealed copper canisters will then be placed in a system of tunnels about 500 meters deep in the solid bedrock. The copper canisters will be embedded in bentonite clay in the spent fuel repository's tunnels. This clay will act as a buffer and protect the canister from corrosion and minor movements in the bedrock. Then they will be embedded in bentonite clay. The final barrier consists of the bedrock itself. The task of the rock is to isolate the waste. It provides a stable chemical environment and protection from events at ground level.
The canister, buffer, backfill, and closure are the main components of KBS3 repository. The tight corrosion-resistant and load-bearing canister is used to encapsulate spent nuclear fuel. The canister are deposited in the crystalline rock at a depth of 400 to 700 meters. Around the canister is a buffer, which is a clay-containing swelling mineral, aimed to prevent water flow and protect canister. If contaminant is breached, buffer shell could also prevent and retard the dispersion of radioactive materials to the background and surface. Backfill installed in deposition tunnels is a key for multi-barrier, which aim to keep the buffer in its right place. This is the cross-section of backfill. Pre-compacted bentonite blocks and highly compacted bentonite pellets are proposed to fill the volume. In those tunnels which is not deposited, such as investigation boreholes, rock caverns, shaft, and ramp, the closure is the materials to install in order to fill and close them.
Okay, let's talk about design premises for a KBS 3V repository. As a part of the planned license application for a final repository for spent nuclear fuel, the Swedish Nuclear Fuel and Waste Management Company (SKB) has developed design premises from a long-term safety aspect of a KBS three-way repository for spent nuclear fuel. The purpose is to provide requirements from a long-term safety aspect to form the basis for the development of the references design of the repository and to justify. Design premises typically concern specification on what mechanical loads the barriers must withstand, restrictions on the composition of barrier materials, or acceptance criteria for the various underground excavations. These design constraints, if all fulfilled by the actual design, should form a good basis for demonstrating repository safety. The justification for these design premises is derived from SKB's most recent safety assessment, SR scan, complemented by a few additional analyses. Some of the design premises may be modified in future stages of SKB's program as a result of analyses based on more detailed science data and a more developed understanding of processes of importance for long-term safety. Okay, let's talk about design premises for a KBS three-way repository.
The unclad spent nuclear film repository is a deep geological repository for the final disposal of spent nuclear film, the first such repository in the world for high-level waste. Postva started construction of the site in 2004. The Finnish government issued the company a license for construction the final disposal facilities on 12 November 2015. As of June 2019, Postva expected operations to begin in 2023. The facility's construction plans are divided into 4 phases. Phase 1, 2004 to 2009, focus on excavation of a large access tunnel to the facilities, spiraling downwards to a depth of 420 meters. Phase 2, 2009 to 2011, continuing the excavation to a final depth of 520 meters. The characteristics of the bedrock were studied in order to adapt the layout of the repository. In 2012, Postva submitted an application for a license to construction the repository. The license was granted in November 2015. Phase 3, 2015 to 2017, construction of the repository. Phase 4, the encapsulation of the barrier of the area filled with the spent fuel is projected to begin around 2020. Prospect forecast. The unclad repository is accepted to be large enough to accept a canister of spent fuel for around 100 years. Until around 2120, at this point, the final encapsulation and barrier will take place, and the access tunnel will be backfilled and sealed.